Berlin, 1940. Adolf Hitler dismisses reports about American industrial capacity. America makes refrigerators and automobiles, he declares. Germany makes weapons. The Führer had studied American manufacturing. He knew Detroit built cars on assembly lines. He knew American factories produced consumer goods in impressive quantities. But consumer goods are not tanks. Assembly lines are not arsenals. This calculation seemed reasonable. Germany produced 2,200 tanks in 1940. The United States produced 0. But Hitler made a fatal error. He confused what America was producing with what America could produce. He saw the machinery, but missed the system. He counted the tanks, but ignored the engineers who built the assembly lines that could build anything. Within 4 years, that error would cost him the war. By 1944, the United States was building a ship every day, a tank every hour, and an aircraft every 5 minutes. The revolution didn't happen on battlefields, it happened in factories, and it started with one impossible order. The call. May 1940. France is collapsing. President Roosevelt knows America will enter the war, but the military is unprepared. The army has 174,000 men. Germany has 4 million. American tank production is measured in dozens. Germany measures in thousands. William Knudsen receives a phone call that will change history. Roosevelt wants him to leave General Motors, where he's president, and mobilize American industry for war. The timeline? Immediately. Knudsen understood automobiles. He had helped Henry Ford perfect the assembly line. He had built GM into the world's largest corporation. But military production was different. A car had 5,000 parts. A bomber had 150,000. A defective spark plug meant inconvenience. A defective aircraft engine meant death. Army procurement officers were skeptical. They didn't understand how a company that made Buicks could suddenly make bombers. But Knudsen saw what the generals missed. The fundamental principles were identical. Both required precision machining, complex assembly, quality control, and massive scale. Detroit had spent 30 years perfecting these skills. The product was different. The process was transferable. Roosevelt gave Knudsen an impossible target: build 50,000 aircraft per year. In 1940, America produced 2,141 military aircraft. The president was demanding a 2,000% increase. Industry experts called it fantasy. The breakthrough came from understanding what Detroit actually did. The auto industry had created the most sophisticated manufacturing system in human history. They had mastered precision machining to tolerances of 1,000th of an inch. They had perfected supply chain coordination, bringing together thousands of components from hundreds of suppliers. Most importantly, they had solved the fundamental problem of scale. The assembly line broke down complex products into simple, repeatable tasks that could be performed by semi-skilled workers using specialized machinery. This was the weapon that would win the war. Willow Run. Charles Sorensen stood in a Michigan field watching bulldozers level ground. He was Henry Ford's production chief, the man who had designed the Highland Park assembly line. Now he was building something impossible. The B-24 Liberator bomber weighed 36,000 pounds empty, stretched 67 feet long, and required 1.2 million parts. Consolidated's San Diego factory needed 40,000 man-hours to build each aircraft, producing one per day at peak capacity. Sorensen promised the government he could build one per hour. Military officers thought he was insane. Aircraft weren't automobiles. Each bomber was handcrafted by skilled workers. Traditional manufacturing was artisanal. Master craftsmen built sections separately, then assembled them with careful adjustment. This worked for hundreds of planes. It couldn't produce tens of thousands. Sorensen saw it differently. The B-24 was a machine with precise specifications. If every rivet was identical, every wire harness the same, every panel exactly matching engineering drawings, assembly became mechanical rather than artistic. The Willow Run plant stretched 3,500 feet long and 1,300 feet wide, covering 67 acres under one roof. Along this length, Sorensen laid out a moving assembly line for bombers. The innovation wasn't size, it was organization. Instead of static bays, Willow Run broke the process into stations. Workers attached the nose section at Station 1, installed the cockpit at Station 2, attached wings at Station 3. The aircraft moved continuously until a complete bomber rolled out the end. This required reimagining everything. Sorensen needed exact interchangeability. Every part had to fit perfectly without adjustment. Ford's tool and die makers built precision fixtures holding aircraft sections in exact positions. They designed jigs ensuring every rivet hole was drilled identically. They created gauges verifying dimensions to thousandths of an inch. The manufacturing approach transformed skilled work into simple operations. Instead of master riveters, Sorensen hired ordinary workers and gave them powered rivet guns calibrated for specific locations. Training time dropped from months to weeks. Willow Run eventually employed 42,000 workers, many with no manufacturing experience. The first B-24 rolled off in September 1942. By 1943, Willow Run was building one bomber per hour. By 1944, production peaked at 650 aircraft per month. Willow Run produced 8,685 B-24 Liberators during the war. At peak production, a new bomber rolled off every 63 minutes. The facility consumed 39,000 tons of aluminum monthly and used 4 million rivets daily. The real breakthrough was philosophical. Sorensen proved complex military equipment could be mass-produced using assembly line techniques. The conversion, what happened at Willow Run, replicated across American industry with stunning speed. Every major manufacturer converted peacetime production to military output. General Motors stopped making Chevrolets and started making aircraft engines, tanks, and artillery. By war's end, GM produced $12.3 billion in military equipment. The Buick plant built 74,000 aircraft engines. Cadillac produced 1,800 tanks. Pontiac manufactured anti-aircraft cannons. Chrysler built the Dodge Chicago plant for B-29 engines. The facility covered 6.5 million square feet, employed 30,000 workers, and delivered 18,413 engines. Fisher Body became America's largest aircraft component producer, manufacturing parts for 13,000 B-17 bombers, 15,000 B-25 bombers, and 10,000 other aircraft. But conversion required complete retooling. A stamping press forming car fenders needed new dies for aircraft panels. Tool and die makers became the war's invisible army, building specialized equipment from engineering drawings. The machine tool industry expanded explosively. In 1940, American factories contained 938,000 metal-cutting machine tools. By 1945, that reached 1.5 million precision instruments. Coordination was equally challenging. A B-17 required components from 35,000 separate suppliers. The Production Requirements Plan created a centralized system tracking material flows and identifying bottlenecks. The results were unprecedented. In 1941, American factories produced 452 military aircraft. In 1944, they produced 96,318. Tank production increased from 4,052 in 1941 to 29,497 in 1943. Artillery production went from 7,000 to 90,000. American factories produced 41 billion ammunition rounds, 12 million rifles, 2.6 million machine guns, 300,000 aircraft, and 89,000 tanks. But the most important production couldn't be counted in units. America built production capacity itself. Every new factory, every trained worker, every refined process increased the ability to produce more. This compounding effect created exponential growth. The shipyards. The maritime transformation was equally dramatic. In 1940, American shipyards delivered 102 ships. In 1943, they delivered 1,949. Henry Kaiser had never built a ship before the war. He was a construction magnate who specialized in large projects like Hoover Dam. When the government needed merchant ships to replace U-boat losses, Kaiser promised he could build them faster than they could be sunk. Traditional shipbuilding was sequential. Lay the keel, build framework, install machinery, add superstructure. Skilled shipwrights worked on each vessel for months. Kaiser revolutionized this by applying assembly line principles to something that couldn't move. He built ships in sections at different locations, then assembled them in dry dock. The Liberty Ship program demonstrated results. These 441-foot cargo vessels were Allied logistics workhorses. Traditional construction required 8 to 12 months. Kaiser's Richmond shipyard reduced this to 42 days average. The record was 4 days and 15 hours for the SS Robert E. Peary. The technique was prefabrication. Instead of riveting each plate on the ship, workers welded large sections in assembly yards. Complete sections weighing hundreds of tons were lifted by cranes and welded at the dry dock. This demanded precision at enormous scale. Each section had to fit perfectly. Kaiser's engineers developed jigs and fixtures ensuring exact positioning. The workforce transformation was remarkable. Traditional shipbuilding required years of apprenticeship. Kaiser trained workers in weeks, breaking complex tasks into simple operations. Richmond Shipyard No. 2 employed 90,000 workers at peak. Many had never worked in manufacturing. They came from farms, retail, domestic service. Kaiser's shipyards delivered 1,490 vessels during the war. All American shipyards produced 5,777 ships, totaling 56 million deadweight tons. This represented more merchant shipping than existed in the entire world before the war. Speed came with trade-offs. Liberty ships were designed for rapid production, not longevity. Many developed cracks. Some broke apart in heavy seas. The military accepted this. Ships that lasted 5 years were worthless if they couldn't be built in time. German U-boats sank 2,603 Allied merchant ships during the war. American shipyards built faster than Germans could sink. By 1943, the Battle of the Atlantic was won through production rather than combat. The numbers. By 1944, the arithmetic was devastating. American factories outproduced Germany, Japan, and Italy combined. The margins were overwhelming. American aircraft production in 1944, 96,318. German production, 39,807. Japanese production, 28,180. The United States alone built more than all Axis powers combined. Tank production told the same story. America built 17,565 tanks in 1944. Germany built 9,161. Japan built 401. Soviet factories added 29,000 on the Allied side. The production advantage extended to every category. American factories supplied not just U.S. forces, but British, Soviet, and Free French armies through Lend-Lease. The U.S. provided 14,000 aircraft to the Soviet Union, 7,000 tanks, and 400,000 trucks. This industrial supremacy changed military strategy fundamentally. German commanders husbanded forces because replacements were scarce. American commanders could afford aggressive tactics, knowing lost equipment would be replaced immediately. American armies in Europe consumed 800,000 tons of supplies monthly. This required 27,000 trucks moving constantly. All American-built. German armies relied on horses for logistics. In 1944, the Wehrmacht used 750,000 horses for transport. This wasn't preference, it was necessity. Germany lacked industrial capacity to mechanize completely. At the Battle of the Bulge, Germans launched their last major offensive with 1,400 tanks. Americans and British countered with 4,000. German forces ran out of fuel within days. Allied forces had unlimited supplies. The Pacific showed similar patterns. Japan built 30,000 aircraft total during the war. America built 300,000. Superior equipment couldn't overcome 10-to-1 production disadvantages. The industrial victory extended to laboratories. American research produced the proximity fuse, making anti-aircraft fire devastatingly effective. The Manhattan Project produced atomic weapons through industrial processes requiring entire secret cities. Hitler's 1940 dismissal of American industry had proven catastrophically wrong. Detroit's assembly lines, operating at scales unimaginable to European planners, buried the Axis under an avalanche of steel. The lesson: the transformation didn't end with victory. Techniques pioneered at Willow Run and Kaiser's shipyards became standard practice. Management systems developed for war production influenced every subsequent manufacturing revolution. The workforce changed permanently. Millions learned precision manufacturing skills. Women proved their capability in roles previously reserved for men. Wartime wages transformed American society. But the deepest legacy was philosophical. American industry demonstrated that manufacturing itself could be manufactured. The ability to produce wasn't fixed. It could be expanded, refined, and deployed with stunning speed when purpose and resources aligned. Hitler had been right about one thing. In 1940, America made refrigerators and automobiles. He was wrong about what that meant. The factories, the engineering talent, the production systems that built consumer goods could build anything. And when turned toward military production, they built victory through overwhelming material superiority. In modern industrial warfare, productive capacity matters more than martial tradition. Detroit didn't just win the war. It proved that the assembly line, that symbol of American consumer capitalism, was the most powerful weapon ever created. Subscribe to see more stories about the machines and systems that changed history.